All right, we're going to be going over sprint number 29 from today's contest. Sprint number 29 reads, Yaya has cards labeled with whole numbers from 1 to 6 inclusive. She swaps the placement of 2 cards in each turn. After at most 2 turns, the cards from left to right have been sorted in increasing order. Including the possibility of no turns, how many starting orders can Yaya have? So, first of all, we should notice that on every turn, Yaya can at most place 2 cards in the correct spot, because if 2 cards are taking up each other's spot and she swaps them, then they'll both have moved into the correct position. So, if she takes at most 2 turns, and on each turn she makes at most 2 numbers, or places at most 2 cards in the right spot, then before those 2 turns have gone by, she can have at most or at least 2 cards already in the correct position at the start of her game. So we know that the minimum value for X, if X is the number of cards already in their correct spot when Yaya begins the game, is 2. So we only have to consider the cases where X equals 2, 3, 4, 5, or 6. Now, since 2 is kind of a big one, since at that point we'd have to put 4 cards in the correct position, let's start from X equals 6 and move down. If X equals 6, then all of the cards are already in the correct position when Yaya begins the game, so she doesn't have to make any turns at all, and that will give us one case where Yaya's starting order will end after at most 2 turns in the correct order. Now let's say that there are 5 cards already in their correct spot. But if we think about it, since there are 6 cards total, if 5 cards were in their correct spot, then by necessity, the only remaining card has to go in the only remaining spot. So it's also already in the correct spot. So it isn't possible for there to be 5 cards in the correct spot at the beginning of Yaya's game. So we don't have to worry about that case. Now let's move on to X equals 4. If 4 cards are in the correct spot, then Yaya has to choose those 4 cards out of 6. That's 6 choose 4. Or since 6 choose 4 is the same as 6 choose 2, that's 6 times 5 divided by 2, or 15 ways that she can choose the 4 cards that are in the right position. And then the last 2 cards, their position is decided because we've said that there are only 4 cards in the right position, so the 2 cards remaining have to be in each other's spot, and after one swap, they'll be put in the correct spot as well. So that's only one possibility. So there are 15 cases for X equals 4. What about X equals 3? If 3 cards are in their correct spot, then first of all, Yaya has to choose 3 out of the 6 cards, so 6 choose 3 to be in the correct spot. And 6 choose 3, we'll calculate that in a similar way to 6 choose 4. It's going to be 6 times 5 times 4 divided by 6, or 20 ways to choose the 3 that are already in the correct spot. And then for the positions of the 3 cards that are scrambled, theoretically, there's 3 ways to place them, but one of those ways is going to be the correct way. But so since one of those ways is going to be the correct way, we'll only have 2 choices for how to place the 3 that are in the incorrect spot, because for the first one that we're going to place, let's say we're placing the number 4, we can't choose this spot, so we have 2 options, here or here. And then when we're placing number 6, we know number 6 can't go here, so number 6 has to go here. 5 has to go here, for a total of 2 options that we were given. 20 times 2 times 2 is 40, giving us 40 cases when x equals 3. And now for x equals 2. If there are only 2 cards in the correct spot, then not every case where there are only 2 cards in the correct spot will be something that Yaya can complete after 2 turns. Instead, if we have only 2 cards in the correct spot, first we have 6 choose 2, or 15, because we calculated that in x equals 4. 15 ways to choose the 2 that are in the correct spot. And then of the 4 that are left, there have to be 2 distinct pairs of 2 numbers that can be swapped to be put in their correct position. So let's say in this case, 3 and 5 are swapped, and 4 and 6 are swapped. Because that way in 2 turns, first she can swap this first pair, and then on the second turn, she can swap this next pair. And how many ways can we split these 4 numbers into 2 distinct pairs of 2 and 2? Well, if we look at any one of these numbers, then we have 3 options for the number it's paired with. For instance, for number 5, we had 3 options for the number to be paired with, 6, 3, or 4. And for whichever one that it's paired with, we can put 5 into the correct position for that, and the other pair is already decided. So there are 3 total ways to successfully pair up these 4 numbers into sets of 2 and 2, giving us a total of 15 times 3, or 45 cases when x equals 2. And that's all the cases that we need to consider, because if x equals 1, then there's no way that Yaya can place all of the numbers in the correct position in 2 turns. So all we need to do is add up these numbers. You should notice 45 plus 15 is 60, and 60 plus 40 is 100. So the total number of cases is going to be 100 plus 1, or 101 possible starting orders for Yaya to have. That is our answer, and we are done. Thank you.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.